In section 3.2, we are going to talk about the unit circle. So the unit circle usually gives everybody just this cringe, not something that everyone loves, but something that you guys did miss out on a little bit last year. And so we're going to spend a little bit more time on it in this section. And then when we come back in person on Monday or Tuesday next week, we'll spend some more time on it. We'll work on filling it out, work on how you can memorize it. But there is an example in here of the unit circle. So we're going to just work on that today and look at the relationship and the patterns of all the values on the unit circle. We'll evaluate trig functions using the circle and then talk about the domains and the ranges and just using our calculator for that. Okay, so the first thing is the unit circle. So here's your unit circle. Doesn't really all fit on the screen very well, but here's your unit circle. In our last section, we talked about all of the angle and radian measures. So if you notice, it's like the 0, the 30 degrees, the pi over 6, the 45 degrees, the pi over 4. So that's all from the section 4.1. Okay, and if you don't have a good handle on those, that's something that you need to be working on. But the second part of the unit circle is what are the actual points on the circle? And these are just points like on the coordinate plane. So you would go over a certain amount of x and then up a certain amount y, and you would get to this point. And remember, the unit circle is called the unit circle because the radius of the circle is 1. So if we find these coordinate points on the circle, these are these exact values that you ultimately have to have memorized. Okay, so the way that I look at this is when we have these points, you have your x and your y coordinates. Your x is always your cosine, and your y is always your sine. It goes in alphabetical order. So x comes before y, cosine comes before sine. So if we look at this first point right here, our theta, our angle measure, is either 30 degrees or pi over 6, depending on if we're talking radians or degrees. So let's talk about radians in this case. So we'll say the cosine of pi over 6 and the sine of pi over 6. Right? So we're looking for the point on the circle when our angle measure is pi over 6. Okay, so the cosine value is your x-coordinate. So the cosine would be root 3 over 2. And the sine is your y-coordinate. So the sine is 1/2. So when they ask for exact values for your trig functions, we're actually looking for all of these exact values at these points. Okay, lots of different ways to memorize it. Some of you will look, if you notice, all these points inside the quadrants, so not on the axes, but the 3 inside the quadrant. So in every quadrant, you have these 3 points as you go around. And they're all just reflections of each other. So if you know the first quadrant, then you can use your reflections to figure out your other quadrants. But they're all over 2, right? So everything is over 2. If you start at the top, you have the square root of 1, which is 1, then the square root of 2, and the square root of 3. So it's the idea that you go 1, 2, 3, and then you go over here and you go back up. 1, 2, 3. So that's one way that you can memorize it. Starting at the top, go 1, 2, 3 down, and then slide over, go 1, 2, 3 back up. Okay, so if you want to do that, you can memorize it that way. For me, I think just visualizing it is a little bit easier. Okay, because you know that this point is 1, right? So the distance from here to the center of your circle, the distance from here to here is 1. So if you're at this point, if we were to go over here, we're halfway to 1, right? So our y value is 1/2. Okay? And our x value isn't at 1/2, so our x value is root 3 over 2. So the 1/2 and the root 3 over 2 always go together. If you notice up here, the 1/2 and the root 3 over 2 are always together. And again, this one up here at pi over 3, if we were to drop that x down, that x is halfway out here. So that's why x is at 1/2. So that would mean that your y has to be the other one. Your 45 degrees or your pi over 4s are all root 2 over 2s. Okay. So then, if you have that first quadrant memorized, then all you have to think about is the signs, right? So these, your x and y, are both positive. If you reflect into the second quadrant, your x is negative, but your y is positive. So the point at pi over 3 would reflect over to the point at 2 pi over 3. And if you notice, those x and y values are the same, except for the x is negative, right? Because in the second quadrant, the x is negative. And then if we took that point and again reflected it all the way down here, just did a reflection, we have those same coordinates, but because in the third quadrant, your x and your y both have to be negative, those points will both be negative. And then if we reflect it over the y-axis, we get over here, again, those same 1/2 root 3 over 2, but in this case, your x is positive and your y is negative. So that's that idea that if you have that first quadrant memorized, and you know, the other key is you have to know where all these radian measures are, so you have to be able to figure out where those are, then you can just reflect those exact values into the right quadrant and know if they're positive or negative. All right, so moving on to your trig functions, which we talked about before. Remember that the sine of the angle measure is your y-coordinate. The cosine of your angle measure is your x-coordinate. And the tangent of your angle measure is your y over your x. Or you could say that the tangent of some angle is the sine over the cosine. Okay. Cosecant is the reciprocal of sine. So if sine is y, cosecant is 1 over y. Secant is the reciprocal of cosine. So secant would be 1 over x. And cotangent is the reciprocal of tangent. So instead of y over x, you would have x over y. Right? So again, maybe make a note to yourself that cosecant is 1 over the sine. Secant is 1 over the cosine, and cotangent is 1 over tangent, right? So if you said 1 over tangent, you could also think about that as cosine over sine. All right, so evaluating the 6 trig functions. So your 6 trig functions, I'm going to change colors here, this is a little old. Remember, your 6 trig functions are your sine, your cosine, your tangent, your cosecant, your secant, and your cotangent. Those are those 6 trig functions that they want you to find. Okay, and we have as t is 5 pi over 4. So this 5 pi over 4, we're talking about on the unit circle. So on your unit circle, remember your pi over 4s are those quarter marks. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So over here is your 5 pi over 4. Okay? So what might be helpful is to say, well, I know at pi over 4, my exact values are root 2 over 2 and root 2 over 2, right? And we know that at 5 pi over 4, that would just be a reflection, right? 180 degrees to here. But here in this quadrant, everything is negative. Your sines and your cosines are negative. So if we're looking, starting with the sine of 5 pi over 4, it will be the same thing as the sine, which is your y-coordinate, of pi over 4, but it has to be negative. So it would be negative root 2 over 2. Your cosine of 5 pi over 4, right, is your x value. So you look at your x-coordinate, but again, we have to put it in the third quadrant, so it has to be negative. So negative root 2 over 2. And then your tangent of 5 pi over 4, remember, is your sine over your cosine, or your y over your x. So if you have negative root 2 over 2 over a negative root 2 over 2, you just get 1. So then to do the secant, the cosecant, and the cotangent, once you have sine, cosine, and tangent, we're just talking reciprocals. So sine, the reciprocal of sine is the cosecant. So the cosecant of 5 pi over 4 would be the reciprocal of our sine. So if sine is negative root 2 over 2, then cosecant is negative 2 over root 2. Right? If we were to rationalize that, that means we have to multiply by root 2 over root 2. We would get negative 2 root 2 over 2, which would just give us a negative square root of 2. When we have the secant of 5 pi over 4, again, it's the reciprocal of cosine, so we would have negative 2 over root 2, which was the same thing for cosecant. So we know that that would simplify to just be negative root 2 also. And then the cotangent of 5 pi over 4 is the reciprocal of tangent, right? So it's just 1 over tangent, right? So it's 1 over the tangent of 5 pi over 4. Well, we know the tangent of 5 pi over 4 is 1, so you just get 1 over 1, which would give you 1. Okay, so the 4s are a little bit easier, but now if we get to negative pi over 3, so again, we need to think about on our unit circle, negative pi over 3, we know that positive pi over 3 is right here. So negative pi over 3 would be down here, right? And so this has your positive x values and your negative y values. And if we talk about our exact values at pi over 3, our x is 1/2 and our y is root 3 over 2. Right, so that's your x and your y at pi over 3. Which means at negative pi over 3, our x would still be 1/2, but our y would be negative root 3 over 2. So when we go through this and come up with our 6 trig functions, our sine at negative pi over 3, so our y value down here at negative pi over 3 is root 3 over 2, but we know our y value in that quadrant needs to be negative. So we need negative root 3 over 2. Our cosine of negative pi over 3 is the same thing as our cosine at pi over 3 because the x is still positive. So we would say that's 1/2. And then our tangent, negative pi over 3, and remember the sine was your y coordinate and the cosine was your x coordinate, and the tangent is y over x. So our tangent is y, so negative root 3 over 2 over x, which is at 1/2. So when we divide fractions, we would say negative root 3 over 2 times 2 over 1, which would just be negative root 3. When we go to the cosecant, right, the cosecant of negative pi over 3 is just the reciprocal of sine, right, because cosecant is 1 over your y or 1 over sine. So we would have negative 2 over root 3. If we were to rationalize that, we would get negative 2 root 3 over 3. The secant of negative pi over 3, right, is the reciprocal of cosine. So if cosine is 1/2, the reciprocal of 1/2 is just 2. And then the tangent, sorry, we did the tangent, so the cotangent of negative pi over 3 is the reciprocal of tangent. So it would be negative 1 over the square root of 3, which if we were to rationalize that, we would get negative root 3 over 3. And so then you have the domain and the period for sine and cosine. So the domain for sine and cosine is all real numbers. So your domain for your sine and your cosine is all real numbers, right? You can plug anything you want into sine and cosine. However, the range is what can they equal? And in this case, because your unit circle has a radius of 1, so if you look, your x values go from negative 1 to positive 1, and your y values go from -1 to +1. So the range would just be -1 to 1 for your sine and your cosine. So the range, we would say, is from -1 to 1, and it could include the -1 and the 1. So this slide just talks about that range again. It gives you those definitions. And so then the period, because the period is how long does it take before it starts repeating itself. And since a full rotation of the unit circle, in this case, is 2 pi, the period for sine and cosine is 2 pi. So if you needed to find a coterminal angle like we did in 4.1, we just added one full cycle, which was one full period, and we got another value. So this circle shows that if t is pi over 4, it would be the same thing if you added 2 pi to it. Those points on your circle will always still be the same. So you have these period identity type things that says that the value of the sine of t plus 2 pi, so the sine of some angle, if you rotate it 2 pi, it will still equal the same as the sine of whatever that original angle was. Same thing with cosine. If you add 2 pi, you would still get back to that value for cosine. Okay, so if we use that, and then we also have this idea of odd and even functions. Okay, so your odd and even functions, your cosine is even. So if you have the cosine of a negative angle measure, it equals the exact same thing as the cosine of the positive angle measure. And it visually, if you think about that, if I were to rotate this positive theta, or I were to rotate in the direction of negative theta, right? My x-coordinate, which is my cosine, the x-coordinate here would be the exact same thing as the x-coordinate here. So whether you rotate a positive or a negative, your cosine, which is your x-coordinate, will be the same. Same thing with your secant, since that's the reciprocal of cosine. So then what that means for sine and tangent is that those are odd functions. So for your sine, we have the sine of negative t equals the negative sine of t. Okay. Same thing with cosecant, tangent, and cotangent. So if you rotated a negative t, a negative angle, right, we'll call this negative t, right? This sine value down here, this sine value, which is your y value, would be the same thing as if you rotated positive t, right, this sine value, but made it negative down here. Okay, so what you're going to want to do is you're going to want to write down these identities, because we're going to have to use those to help us figure out values. So if you need to pause this, take a minute to write those down, and then we're going to move on to those next examples. So here we're using the period to figure out the exact value of the sine of 13 pi over 6. So 13 pi over 6 is bigger than one rotation. So what might be easier to do is to think about if you have 13 pi over 6, if you subtracted 2 pi from that, so if we kind of unwound it one full rotation, we would have 13 pi over 6 minus 12 pi over 6, which would give us pi over 6. So using that period identity, we know that the sine of 13 pi over 6 is the same thing as the sine of pi over 6, right? Because those are coterminal angles. They both end up right about here. Because if you went 13 pi over 6, you'd go all the way around, which would be at 12 pi over 6 plus another 1, which would give you 13, or you could just go that 1 to begin with. So for this problem, instead of trying to figure out sine of 13 pi over 6, you could just go to your unit circle and say, well, what's the sine of pi over 6? And the sine of pi over 6 is 1/2, which means the sine of 13 pi over 6 is also 1/2. So for part B, we have the cosine of negative 7 pi over 2. So it might make sense to make that positive. So if we took negative 7 pi over 2, right, if we added 2 pi to that, right, so negative 7 pi over 2 plus 4 pi over 2 would get you to negative 3 pi over 2. Right? And if you're not comfortable with negatives, then add another 2 pi to that. So add another positive rotation, which gets you to pi over 2. So what you figured out here is that the cosine of negative 7 pi over 2 is coterminal with the cosine of pi over 2. So now you just go to your unit circle and you look for where pi over 2 is, right? And pi over 2 is up here at the top. And the cosine up there is 0, which means the cosine of negative 7 pi over 2 is 0. Okay. And then for part C, this one's a little bit different. This isn't your period, this is your odd and even functions. So remember when I told you to write down, if you look at the sine of negative t, you should have written down that that equals the negative sine of t, right? So if we know that the sine of negative t is 4/5, right, then don't we know that the negative sine of t is also 4/5, right? So we know that the negative sine of t is 4/5. Which means then that if we move the negative to the other side, we could say that the sine of t is negative 4/5.